Hi everyone, welcome to topic 5 of your crash course in R. Today we'll be talking about how to build apps with RShiny. I've included here a link to a tutorial from RStudio, so if you want a deeper dive, I highly recommend this. But before we get started, you might be wondering, why even use RShiny? What can RShiny do? I've included here a gallery of applications, and just to show you the breadth of what RShiny can do. So we have everything from games that we can create in R. We have cool visualizations that are highly interactive. So if I choose different players, I can filter the graph. So every time I'm changing my player, the graph is changing. So the reactivity is really cool. I can change the colors. I can also look at maps in R. So this is a map that's interactive. The key is really interactivity here. So almost everything that is in RShiny tends to have some sort of reactive component. Yeah, so I would highly recommend exploring this gallery if you want to see everything that RShiny can do. But basically the idea is using R to create some sort of application that is interactive. And when I say interactive, I just mean that it allows a user to make changes like choosing a player and then have that change some sort of. But how do we create these applications? And how are RShiny apps any different from a typical R script? So like I said, we're building this within R, so it's important to understand how an RShiny app is different from a typical R script. While RShiny apps do take code like a typical R script, RShiny apps have to have 3 important components in order for them to run. The first is a user interface object. The second is a server function. And the third is a call to the RShiny app function. Now, what do these mean? The first, like I said, is this user interface. This controls the layout and the appearance of the app. So you can think about this as the way to format not only where you want different components in your app to live, but also how you want your app to look. The server function, on the other hand, is really where the meat of your code happens. This is where you'll create plots, where you'll create data frames that will be reactive, and I'll talk about that later. And this is just telling R how to build the app. The third is a call to the RShiny app function. Now, this might sound a little bit confusing, but this is actually the simplest part. It's just telling R that we should create an app using this RShiny function, and it's telling R what my user interface are and my server are. So this function is built by the RShiny package in R and just tells R how to actually compile these 2 components together. So now let's go through an example. Let's talk about how these 3 components might look. So this is not going to run, obviously, because this is just a dummy example, but I want to show you what your app might look like. So everything that's in between these hashtags, starting with app start and app ends, is an example of what might be in your application. Of course, this is just a really basic example, but I want to walk through it to show you how this works. So what we have before this UI, and I'll actually mark this regular code here. What we have right here before we start this UI is just regular code. So this is commensurate to an R script. Anything you put here, R will treat it like typical code. You don't have to do anything differently. So this is where you'll load packages, where you'll load your data set. If there's any data wrangling you want to do, you can do it before you call your UI. Then once we have the UI, which if you'll remember is the user interface, this is how we're telling what we want our app to look like. So you'll first use this fluid page to tell R that everything you're using is going to tell it what you want your page to look like. You'll first notice I use this title panel, which is just telling R what I want my app to be named. And then the second is this sidebar layout. And this sidebar layout is just a way to put all of our different components into R. There are a bunch of different ways that you can actually lay out things in R, and I've included the cheat sheet in the materials, but essentially you can put things into rows. You can have a split layout where your screen is cut in half. You can have vertical layouts. Like I said, I'll be using this sidebar layout, which is very similar to the example we looked at with the soccer players. So we have the inputs, which is called the tab panel, and then we have our main panel, which is really where the main focus of our app is. So inside this sidebar panel, we'll then be able to specify how we want our sidebars to be set up. So I've included this tab panel, which is, like I said, this right here, and then our main panel. And what we have in our main panel is this plot output. So rather than just saying plot, we're going to say plot output because we're working with our Shiny. And then we have this output ID equals dist plot. But if you'll notice, nothing I did up in the regular code or here calls dist plot. So what is this? This is the reason that we haven't called anything here is because we're actually not specifying what this plot should be in the UI. And this is because, like I said earlier, the UI is really just dedicated to making your app look a certain way. You're not going to be actually making plots in this section. This is just where all of the formatting lives. However, if you scroll down to the server side, you can see that this is where we create this plot. So we have this output $, this plot, and then we have our histogram. I'm going to explain how this is different from a typical plot in a second, but I just quickly want to show you then the final component is that we just have this line of code which connects our UI and our server. So this is what a very, very simple version of a Shiny app could look like. These are the basic components that you would need. But beyond using the UI server and Shiny app function, is there anything else that's different? Yes. First is that our Shiny can be pretty particular about naming conventions. So you'll need to make sure that your app is actually named app.park. This is going to be weird if you have multiple applications, of course, but just make sure that you're keeping everything in their own file, and that file should have a unique name that tells you what it is. The second is that everything in your app needs to be saved in that same folder as your app. This will really, really help in making sure that you're able to load your app every single time. And the final thing that's kind of particular is that any images or videos that are in your app need to be saved in a folder called www. So if we look at this app right here, we can see that I have my app file, have my data frame, have my styles.css, which is basically just a file that adds some additional formatting. Feel free to use my CSS file if you're interested. And then I have this subfolder called www, where I have these two pictures that I use in my notes. The second thing that's different is that our Shiny allows for interactivity. So we'll need to use some reactive functions. You can think about reactivity in a similar way as global variables. So in order to calculate a multiplication problem, for example, you can go ahead and specify the numbers individually. So say we want to do 2 times 18, so just write 2 and 18 and assign them to math output, and then we get, when we call math output again, we get our number. However, you can also use global variables to do the same thing. Global variables just means that you're using dummy variables in place of the actual numbers. And of course, I'm just talking about a multiplication problem here, so it doesn't have to be just numbers. Global variables can be anything you want. And this allows us to update our global variables without making changes to the rest of our code. So something that can be really helpful, especially if you have tons of manipulation that's happening, is rather than updating your code everywhere, if you decide you want to change 2 to be 3, is actually just using these global variables to stand for 2. So instead of doing 2 and 18, you could assign the numbers 2 and 18 to a global variable num1 and num2. Then you can go ahead and use the same thing, except rather than including the number, you're using these dummy variables. If you do this, we see that we're getting the exact same output. Why might you use this? You might use this if you want something to be interactive or more flexible. So for example, imagine you want your user to be able to specify specific values for number 1 and number 2. You can do this by creating global variables. So this would be a way more efficient way of doing it than actually multiplying every single number combination in case your user is interested in that. So this, I want you to think about this in terms of what we have here. So imagine now that this right here is our num1, whatever this value is, and this is num2. So rather than having our specified specific values, let's say between 50 and 63 and 55 and 70, we basically have a dummy variable that's living behind this input that makes sure that whatever a user puts, it's still going to run. And this is exactly what we're doing here with dummy variables. But what about these reactive functions? So you'll see here we had this weird render plot earlier. What is this? There are a couple of different reactive functions. I've included the Shiny cheat sheet that has a list of tons of different reactive functions, but I'll show you a couple specifics. Render text, for example, will render text based on specific inputs. So again, your inputs are the inputs we've used here. Basically allows your graph, your table, whatever your interactive output is, to update based on these inputs. So for example, if we want to use render text and we want to tell people which variable they chose. So we could have something that says render text, which makes reactive text. You chose, and then this input $ compare cross is actually what we're talking about when we say this global variable. Like I said, all of these inputs are connected to some sort of dummy variable, for example, and the compare cross is exactly an example of this. So I've included here what my code actually looks like to create one of these questions. But what we can see here is that I have this compare cross, which is this input ID name, which links up to what is after this $ here. Then I have what I want the question to actually be showing. So for example, this might say choose a player. Then I have all of my choices. Just like we have all these positions here, I have a list of choices that are in a buttons format. And we'll talk about these buttons in a little bit. So essentially, what this is doing is it's allowing the text to say you choose X based on whatever people chose up here. So say someone chose race, what they're going to actually see is you chose race because I've used this global variable. And you can already see how this is more efficient than creating 3 different versions for each of these different permutations. You can also create reactive functions. So a regular function looks something like this. We have the function name, function, and we say paste, and then include whatever this variable is. However, a reactive function is a little bit different. In addition to having the typical components of a function, we have all of them wrapped in this reactive function. And this is going to come up over and over as we're using our Shiny apps because almost everything we're doing is reactive. You can also render a plot by using this render plot function. So how does this look different from a typical ggplot? A typical ggplot might look like this. We have our data argument, we have our AES, and then we have our geom. However, our render plot looks a little bit different. It has 3 changes. The first is that we're assigning it to an output. So we have this output $ plot name. Then we have this render plot graph. So what you can see here is typically the ggplot would just begin here, but we actually have render plot around our ggplot. The third is that our data argument is now reactive. So rather than just saying something like our data name, we have our reactive data frame. You can always tell that something is reactive if it has parens around it. Okay, I know that this is a little bit confusing, but let's just take a quick second to recap what we've done so far. First, we talked about what components a Shiny application needs. So it does have areas where we can include regular code, but importantly, it needs a UI which tells it how we want our app to look. Do we want it to have a sidebar panel and a main panel, or do we want to have it be just one panel with multiple tabs? All of these are decisions that you'll make in your UI. Then we have this server. This is where we're creating our output. This output could be plots. So right here, we see that I'm plotting my output with this disk plot. We can also create reactive data frames here. We do all of the meat in this server. And finally, we have this Shiny app function, which is just connecting the two pieces together, the server and the UI, in order to actually run this. And we've talked about some really important naming conventions, so make sure that you always follow this when you're creating apps. And we've also talked about how to create reactivity. And like I said before, you can think about reactivity in the same way as global variables. You're just creating code and writing code in a way that you can change your code depending on what a user selects. We've already talked about a couple different types of output. We've talked about render text, so rendering text based on people's inputs. We've talked about rendering plots based on people's inputs, but we could also render reactive data frames. So this blood banks, which has a reactive data frame because we can make different inputs. So if I write 102 here, I'm now seeing that my data frame is filtering. And we can do this in a very similar way. So this looks a little bit funky, but basically what we have here is we have our reactive component, which is the word reactive followed by a paren and a bracket. And we're telling it to return our data frame. And then after here looks like classic dplyr. So what we're doing here is we're filtering this data set depending on the person's input. So in this case, we're filtering for whatever your user said you want this input called job type to be. So I know this is all probably a little bit confusing, but I have two examples of apps that you guys can use as a baseline to tinker with. I think it's really, really helpful to start with apps that are already built rather than creating new apps because as you can see, there's a lot of components that you need in order to do this, and it can be really easy to forget the bracket, for example, and then your code won't run. So I certainly recommend using some of the examples I'll give you, and you can download this with the materials file. So now that we have this reactive data frame, you might be saying, how do we actually create some sort of table like this? Well, we can use render table and then just actually put in our reactive data frame here. Please don't forget to include these parens because it won't work otherwise, and it's not something we're used to doing with data frames, but it's really important for our training. Okay. So we've now talked about the basics of what you need in order for an Shiny app. And before we actually go through two examples, I want to tell you how you can actually deploy your Shiny. And this just means that you can basically put your app on the internet. Of course, you can always share your app locally. So this means if you send someone all of the code and data frames, essentially send them the folder that you use to create and run your app, everyone will be able to run it on their own machines. But if you want to share your app via a link, then you need to actually deploy your app. And you can do this a couple of ways. First, your university may already have a subscription to our Shiny server. So this is something worth asking anyone who might be using our Shiny apps, anyone who has our Shiny apps in your university or company, this is a good thing to ask. Your university might also have Heroku subscription. This is another way to host apps. And finally, if you want to just use something that's totally free, and if it's just for you, I think using the free version of our Shiny server is a great option. Note that you're limited in your number of apps. You can only run 5 apps, and you only have 25 hours of usage a month. So make sure that if you do send this to people, you're telling them that they should close the tab when they're done with it, and so that it's not running up your apps. Okay, let's try an example. So I've included 2 examples in the materials folder. One of them includes a lot more specifications in terms of formatting, but they both do very similar things. So I'm going to go ahead and run both of them just to show you before we jump in. So what you're seeing here is an application that looks at Diva Pager's 2003 data. And what she was looking at is if she gave the same resume to different companies but varied two things, the race of the potential applicant and the criminal background, what would happen? Who would get a call back about their resume? And what I have here is, again, we have this sidebar layout, and I'm allowing users to update information about how different features affect callbacks. So here we have the applicant's race, their criminal record, and so people can filter by race, criminal record, or race and criminal record. They can also specify other things in the data set, like did the employer interact with the candidate, whether the job type was manual service versus customer service. And you can see here that I've included a couple of different tabs. I have this about page, I have this visualize page, and I have a page that produces a table to actually tell you the mean percent callbacks. And we see here, if I update the inputs here, what I see in the numbers tab differs. What I see in the visualize tab differs. And just to do a little shout out to her data, what she finds is that Black applicants with no criminal record were seen as equivalent to white applicants who had just been released from prison. So this is pretty striking, and I think an important finding. So that's one of the reasons I'm using this as an example, just to raise awareness of this. But this is version 1 of the application. If you want to view it in your browser, you can also do that just by clicking the View in Browser tab at the top. But now let me quickly show you the other version. So this is another version of the app, but this has a lot more HTML specifications. This one takes a little bit longer to load, but it does something very similar, except it doesn't have tabs, has an image in the background. And the reason I'm sharing this with you is just because, like I said, the actual formatting of this is totally different. And so I thought that it would be helpful to share two versions in case one of them has the look that's more similar to what you would be interested in. But let's go ahead and talk about just one of them. So let's use the one that has the more classic formatting because I think it's easier to follow. So what I have here is all of our libraries. So this looks exactly like what you're used to seeing. I'm also loading in my data. I'm doing some data wrangling here. This should all look super familiar and it should look exactly like a typical R script. However, we start seeing things a little bit different once we get to our UI side. But let's rerun the app and let's go through the code side by side with what we're seeing. We again have the UI side, and this is where we're specifying what everything looks like, what the input should be. Let's make this a little bit smaller. Okay, so the fluid page should look familiar. This is the start of all of our UI code. Then you'll notice a couple new things. We first have this navbar page, which tells us that we want to have a couple different, this is what we have here. Then we have our sidebar panel, and this is what we have right here with Explore the Data. Like I said, I've included some HTML here, so don't worry about this stuff too much. The stuff that I'm going to be talking about is the really important stuff. Everything else is just additional specifications. So like, for example, this is changing the font of the page, but the stuff I'm not mentioning means that the code would be able to run without it. It's just extra formatting to make it look exactly how I want. Okay, so in addition to telling us we want to have a sidebar panel, we also have these inputs, which are really important. And the inputs happen like this. We'll first choose the type of input. So you can see I have 3 different types of inputs. I have this drop-down menu, I have this select one, and this select all that. And the way that I have this is by using different types of buttons. So the select input is this drop-down menu. The radio button is this yes or no. And this checkbox input is the one that's the select all the. Although the initial part of them is different, so we have the different names, they all have three similar components. So they have the input ID, which tells you what this is essentially our global variable is. The next component is what you want to actually display. So this is whatever your question name is. So for example, applicant race and background. For the next one, it's didn't the employee interact with the candidate? This is the question that is going to appear or the phrase that's going to appear to your users. The final element that we have is the choices. So for example, for the first question, we have three choices: race, criminal record, and race and criminal record. And something that is a little bit different is rather than just using our concatenate to actually tell it the three things we want, the reason that we have this race equals black mutate is because this maps onto the level or column name in your data set. This is really important because you want someone clicking one of your inputs to actually be able to be connected to something in your data frame. If you don't have this, then it's not really going to be a global variable because if you change this, it's not actually going to be capable of changing anything in your data frame. So those are the three components of a question. We have the actual question ID, which is what you'll use to call this input later. We have the stem, and then we have the choices. And as always, if you do double question mark and then the argument, you can check out all of the arguments. So for example, you can see more information about additional things you can do, like you can change the width of it. So I recommend when you're first getting started, looking at some of these different documentations for different types of buttons so you can get familiar. I also recommend checking out the cheat sheet. This has all of this information here as well. So we've talked about how to create questions that will actually update either a data frame or a plot later on. This is all, again, our inputs. You can also have people download data by using a download button argument. And you can include multiple tabs by using this tab set panel. And what I've done is essentially I've used different tab panel arguments to create different tabs. So what you'll see is that the first thing after this tab panel argument is going to be the name of the thing. So we have something that says about the demo, start here. We go to the next time tab panel appears, we can see it happens down here with visualize, which is where the plot lives. And we have another one that says the numbers. I know that I'm skipping through some stuff, but that's just because I'm trying to give you a very focused introduction of the features that you'll need in order to make your code work. All right, and then that would be the end of my UI. So some things I didn't mention is how do I actually get my plot or my table to appear? And we've actually already talked about this. So we're using the functions table output for the tables and the plot output for plot. So this is something we mentioned earlier, but now we can see how it would actually appear in a real RShiny app. Okay, like I said, I urge you to look at some of the HTML information to understand how we can use paragraphs or tags to really specify the formatting. All right, so that's everything on the user side. That's specifying what things can look like. I also recommend going back to some of the galleries if you'd like if you like a different layout. You can also check out the other version of the app if you wanted to look more similar to that. But tinkering from apps that already exist, like I said, is definitely the easiest thing to do. All right, once we're on the server side, this is where the real action is happening. This is where we're creating our reactive data sets, our reactive plots, and our reactive tables. Let's go ahead and rerun the app so we can do this side by side again. So imagine we have this visualize tab, which is printing one of three plots: the race plot, the crim rec, and the race crim plot. And these, of course, map on to the applicant race and background. So if I click race, we're seeing the race plot. If I click criminal record, I'm seeing the crim rec plot. And if I choose race and criminal record, I'm looking at the race crim plot. So how do we create these? Well, we talked about this a little bit already. Don't mind all this extra stuff. This is just formatting for what it looks like. But what we do is, like we talked about earlier, we have this render plot function. And then we use our reactive data frame that we've created in a very similar way that we've done here. Now, the important thing is that we need to actually specify the name of this plot. So this output is this race plot. And if we look before, we can see that we're actually calling this as a plot output. So make sure that your naming is super consistent across your UI and your server. Otherwise, it's not going to work. Okay, so we're creating our reactive plots by using these different render plots. And we can create our reactive data frame by using this reactive function with return data frame. And we're doing all of our filters, except the addition is that rather than having just a variable name, we have to use our global variable as what we're filtering. So what this allows us to do is basically filter the data. So this is a column name in our data frame, and we're filtering it for whatever our user specifies. So our user is specifying yes or no for whether or not the employer interacted with the candidate. And by using this kind of global variable, what we're doing is we're allowing our data frame to be filtered based on this specification. We can do the same thing for all of the other inputs. And then once we have this, we're basically using typical dplyr to select a couple of columns and summarize our data. Then once we have this data frame, we can use render table to put this into a table that will actually be reactive. So there are kind of two steps. First, filtering our data set based on user inputs, and then summarizing it for the values we want to include in our table, and then using this render table to actually put this new data inside a table that looks nice. Okay, so we've done this a couple different times because we have a couple of different plots and tables that can appear, but that's the basic idea, is that in our server side, this is where we're using our reactive data frames and our inputs. There's another input, and our inputs in order to make our applications interactive. And remember, anything that's specified, and when I say specified, I mean created, in the server is going to be called an input. So for example, this manual skill is called an input because this is one of our button names. We had this input idea equals manual skill, and this was whatever people said here. However, we also see things called outputs. So if we look at this plot output, something is called an output because it's been made on the server side. So just make sure that you are paying attention to that, not accidentally including something as an input when it should be an output. But things are input if your user is specifying them, and things are output if it's something that is a product of some sort of interactivity. Of course, not everything here is reactive. So all of this text is going to stay the same regardless of what I click. And the way that you write something like this is actually pretty simple. You're just using helper text, for example, or you're using this paragraph to actually paste text here. I've included some different types of HTML. So tag strong will bold something. So if we see then visualize, we can see that the word visualize is bolded. I've also included bolded and italicized with tag strong and tag M. And we can even include links and pictures within our Shiny apps. Okay, that is everything. I know that was a very intense introduction, and I really think that the best thing to do is go through this and start making changes. So make changes to the title and see how that updates things. Make changes to the number of inputs and see how things change. Because I know this is a lot and I can't possibly go through every single line of code here, but what I've really tried to do is talk about the main features. So how to create different types of panels, how to create tabs, how to write plain text, how to put plots on your code, the different types of inputs you can have and what components they take. And then also I've included code, and we've already talked about it a little bit in the previous script, about how to work with these interactive data frames, how to create plots, and how they're different from typical plots in R. I'll make sure to include more resources on the course page because I know this is complicated, but I hope including these two apps will be helpful resources to get started.